Hello students, and welcome to the week 5 example 4 video. So in this video we will be making the bell crank, which is example 5.4. With your research that you're already doing in conceptual designs for your project, you should be familiar with bell cranks by now, at least on the surface level. So again, open the sketch on your own side if you want to follow along, and yeah, let's get started. So very important from this week, or specifically from this week on, we will be using a few of the properties of the part that you have made to assess you, to simplify marking. So it's very important to make sure that you have your model at the correct position, to have it, the coordinate system in the correct place. So you will see that the bell crank is lying on its side, with the z-axis going through the middle hole, with it being in the middle of that part. So make sure that you have your model in the correct position, otherwise your center of mass and a bunch of other properties will be incorrect, and then you will lose marks for that. Okay, so let's get started with this sketch. So I'm going to sketch it on the top plane. As you can see, there you have the most features, because the thing is, you want to have the least amount of sketches, the least amount of features in your feature tree, making it as simple as possible. So if you draw it on the top view, you can create the majority of your features and then just extrude a few parts. Okay, so we're going to start over there. Okay, first I'm going to begin by adding my base circle there. So that's the circle with a diameter of 22. So I'm going to put it in there, 22. There we go. And just move that, and then just zoom in a little bit. There we go. Okay, then we have our two other circles. So we have one over here, which has a diameter of 16. So I'll type that in, and over here, so it will automatically want to add the same size circle. So I'll just close that and then change this one's diameter to be 10 millimeters. Oh, it wasn't typing. 10 millimeters. There we go. Okay, then also from the sketch, you can see from the center lines that this circle is in line with the center of this circle, which is the origin. So I'll say point on curve. Then this one, the same, except it's for the horizontal. So that's correct then. And then I'll add their dimensions over here. So this should be 80. Oh, it wasn't typing. 80, there we go. And the vertical over here should be also 80. Okay, quickly just zoom out a little bit. There we go. Okay, so that's the starting point. Now we also have our outer circles going around these, and I'm going to add them as well, because I'm going to use them to anchor all the connecting pieces to. So that one has a radius of 16. So it might be a bit ambiguous to what exact line the radii are showing for these outer circles. Some students asked last year, does it show to the inside of the chamfer or the outside of the chamfer? So the dimensions are added for the, or are shown for the outside, because the chamfer is something you'll add at the very end. So you first construct it to the dimension, and then you just add your 1 millimeter chamfer around. So the 16 shows points towards the outer line. So I'll add that circle, and very important, now the radius is 16. Okay, so not the diameter. So 16, oopsie, not 165, 16 times 2, enter, there we go. And then I'll just reset this one by closing and opening, and this one has a radius of 10. So 10 times 2, there we go. And remember what I said about not doing the math yourself, because then you can make a mistake while you're working. Oh, and before I forget, then we also need our arc over here that goes around this one, and that will be the start of our outer form. So that has a radius of 22. So they're all, I took the diameter and just gave it to the radius of the other ones. Okay, oopsie, I had it on the incorrect one. I want to use center and endpoints. So let's try that again. There we go, that's better. Okay, so from this point up to here, you can see there is a straight line. So I'm going to add a line over here. There we go. and we're going to make it tangent to that point, and make these points tangent as well. There we go. And then I have an arc going over here to this one. So for that, I'm going to use the arc by 3 points, because I don't have detail or information about the center point of this arc. So I'm going to connect it to this one and connect it to this one on this side, and click. So you can see it automatically added a tangent constraint here while I was busy. Let me just show that to you again. So arc, this point over here, and you see you can see the tangent, but he didn't do it over here. So I'll also show how to add constraints by opening the constraint dialog, because some people, so if you click on this and click on this, it pops this up. But if you move too quickly, then it doesn't pop up. So if it doesn't pop up and you're struggling, just click C on your computer and it will ask about this, fine. And then you can select your constraint. So I want to do the tangent constraint, and I want it to automatically do selection progression. So otherwise I need to click this one, and then click here and click this one. If I say automatic, it will automatically switch. If I click this one, it will switch automatically to this one. So then I can say this one. And now I'm also not struggling with my selection. Is it the arc itself or is it the center point? Because for tangent, it will automatically do arcs or lines for that matter. So then you don't have a problem with that. One problem that we do have at the moment is that these points aren't actually connected to one another. So for that, we're going to do coincident. This point, there we go. Now they are connected. Okay, I'm going to close this and move a bit. Okay, so this arc has a radius of 45. It's important always to try and add dimensions as you go along. Otherwise, you may have issues. Okay, so we don't have more information about this guy yet. Okay, wait. I see this point wasn't actually coincident with this. It was supposed to be. So if some dimensions don't make sense, try and put it around and see, okay, something's weird. So I'm just going to take this one, and then make that coincident. There we go. That makes more sense now, because you don't need a dimension for this, because this length is already specified and it's connected to this. Okay. And I also need this radius. I thought I had put it in, apparently not. 22, there we go. Okay, fully constrained so far. So now we just need to add this straight line, this arc, and then the final arc. And very important, look at the note there. At this point, there's a note that says the 100 radius arc, that's the one that will come in like this, is tangent to the circle with a diameter of 10. So it will be this circle inside here. Okay, but let's get started with this. I'll use the profile tool because I have a bunch of connected lines. So I'll start with a straight line. That's all good. So I'm just going to say I don't want it to make it horizontal. I just want it to be on this. There we go. Point on curve, not center, curve. Then automatically wants to make it tangent, which is good. We go down here roughly. Then I want to add an arc. So you see it wants to go this way, so you just go in here and sort of pull it out like this, and then it automatically figures it out. So I'm going to click that, and then I want another arc and pull it out again, and then I'm going to connect it to this. So I just want it to be on the edge, and I'll add a tangent constraint in a moment. So point on curve. There we go. So before this throws it to a weird side, I'm first going to say this and this should be tangent. There we go. It looks a bit weird, but don't worry. We will add the dimensions in a moment and it will make more sense. I'm first going to specify this point. Otherwise, everything can move a lot. And as you would have seen with your week 3 homework, that it can be quite difficult when you have a bunch of arcs connected to one another that tend to jump around a lot and want to become circles. So let's avoid that by fixing them. So wrapper dimensions, I'm going to go from this center point. Actually, no, I'm going to go from the vertical because that's, so if I move something here or delete something here, I can break that other dimension. Now if I go from the origin or from the this vector, then I'm not accidentally going to delete the reference. So I'm going to add this one, and that dimension must be 29. There we go. I'll just zoom out a little bit and move this dimension just up a little bit so that it's out of my way. I'll also move these ones so that it doesn't clutter up the place. There we go, that's better. And then we have a radius of 10 over here. Close, but nice to go. There we go, that's better. And this one has a radius of 100. Okay, that's better. Okay, so now we just have one more dimension to add. You'll see one auto dimension. So it's currently saying that this distance, you decided to specify this one. This distance is that, but we don't want to specify it with that distance. We want to specify it from the horizontal or from the origin. You're going to right click because it wants to select the center of this arc. I want to say select from list. I want the sketch origin. And then I want to go toward this center point. And I want the vertical dimension. And that should be 45. There we go. Okay, now my sketch is fully constrained. Very simple, easy. So finish that sketch. So now, I'll just quickly save that. So you also see I'm using the same file I used for the previous part. Or did I add this to the... Where did that go now? It appears I accidentally clicked Control Z instead of Control S. So I just undid my entire sketch, but I just redid it. So we're back. Okay, so now we need to extrude the part. So you have a few ways of going about this. So since you see this bow crank is symmetrical around the XY plane, a good idea is to only make half of it and then mirror the rest. So for this, it's not a very complex part, so it's not that much more difficult to just make everything individually. But as your parts get more complex, it's good to be in the habit of minimizing that duplication of work. So especially so here you have chamfers and so on that will be on these edges later, and now instead of putting a chamfer there and at the bottom as well, you can just add them once and mirror it. It might not seem like a lot of time savings now, but if you have a much larger part, it will save you time in the long run. Okay, so let's get started. So first I'm going to extrude this back part, but before I do, I'm just going to, okay, so I see I did make not a mistake, but something that I will have to change in my sketch before I continue. So you'll see that the bow crank has a cylinder going up here. And you see I don't have a full circle over here to work with. So I'll need to actually add a full circle. So adding a radius was, or just an arc was erroneous. So I'm going to just add a circle here very simply and make it tangent. There we go. Quick and dirty, just adding that circle in to actually use. So you will see it's still fully constrained. There we go, fully constrained. So I just added it there. What would have been better is to, instead of add an arc here, just add the circle from the start. But it is what it is. Okay, so extrude. So first I'm going to extrude this circle. So I gave you a dimension, so very careful, just check. There's the 48 and the 38 dimension. So the 48 is pointing towards this one, which is also the same distance as this one. So the 38 is in reference to this one, as well as the top plane and bottom plane of this one. So I'm going to use this and then say, okay, I'm just going to reset this dialog. There we go. So I'm going to say region boundary curves and go for this one. And then I'm going to start on the plane, because I will mirror later, and then say 38 divided by 2, because if you're in a test and you can accidentally make calculation errors, you don't want that. So let NX do the calculations for you, show results, that looks good. And I'm going to apply. So then I'm going to take this one, and also want to go to the top, but I don't want this bottom part. So it should start at 17 divided by 2. So there you go. That looks better. And then it automatically wants to unite the part. You can also manually say, yes, I want it to be united. So I'll just apply. And then I want to extrude these two. So they start at the same height, but then they go further. They go to that 48 divided by 2. So let's add that in. There we go. And that's still on unite. It will unite with this body. Okay, show results. That looks good. Okay. So now I want to add my chamfer. So it's only on these two. Let me just quickly also reset this one. So chamfer, let me just reset the feature. Okay, so it will be this edge and this edge, but now you see it's a 5mm chamfer. So I'll just click that should be 1, and just click somewhere else to update it. There we go. So that looks correct. Okay, so now we can just simply mirror the part. Very simple. So very important, I'm quickly going to show the incorrect way of mirroring it and then the correct way. So I'm going to say mirror, and then I want to mirror these bodies. So I made all these. Select plane, the horizontal. If you're struggling to select it, just move over here, select it over there. It's fine. Okay, and then I'll just say show results for now, and then you'll see, oh, it broke. So the reason for that is because you are extruding a feature. Now that feature is referenced to something else, but the reference is gone, and that reference is the sketch. So very important when you're busy mirroring features to also mirror all their parents. So these are child features of this parent feature. You can always, and we could just cancel here. If you see this one, if you select this extrude, you will see the parent feature is highlighted here in a pinkish purple. So if I click this one, both of these are its parent because it's united to this, and this is used for the actual geometry. And this one, the only parents are this one and this one. Even though these two are united, this is the base one. So if something else is a parent and this is the base one, so then it will be reference to that. I hope that makes sense. And the chamfer is only in reference to this extrude because it doesn't actually touch any of the rest. Okay. So very important, we want to have the reference for all the other parts. So for instance, if I mirror all of these and then I just mirror the chamfer, that should also work because the extrude is already chamfered. But yeah, always remember to mirror the sketch as well, otherwise you will have problems. So I'll just select that again, say okay, and there we go, there it actually worked. But very important, at the moment, say selection filter, solid body, these are two separate bodies. So we just want to unite them. So I'll go to unite, select this one, select this one. Okay, now they are one body. I'll just hide this sketch, and also I'm just going to go over here and just say hide sketches. I don't want them to show now. Okay, so now important for uploading your homework. So that's the part, that's it finished. But for uploading your homework, it's very important that you actually have the correct material, because if you don't have the correct material selected, then your mass won't be correct. Okay, so the material I specified was ABS, so you can click on that and just click here, though that's because I'm in solid body at the moment. If I'm just in no selection filter, it's probably going to struggle to actually select the body. So you can right click, select from list, solid body, and then I have this option, or let me just click there, go to menu, tools, let me just see here, materials, assign material, select body, and then I can select ABS. Let me just close this, or make it shorter so it actually fits in. Okay, it's selected on ABS and the body, apply, there we go, check mark, it's being used, cool. So now I want to actually add, or actually see what are my properties so that I can use it to fill in the homework. So first go to application, and sorry, not application, I want to be at analysis, sorry, the wrong A. And then I want to go over here, show mass properties panel. So if I go here, there we go, mass properties, see it's all empty. I first need to update my mass properties because I now added a material to this. So I'm just going to update this, and now you see this is all updated, but this is not all the information that we actually want. Well, it's actually a lot of the stuff is here, but it's also very difficult to mark your stuff if you just give us the answer now, and we need to go navigate and try and find all your information. So I'm first going to show you here. So select from list, we want to select the body again, and then from there you want to go to analysis again, and then measure. So since you already selected the body, it will automatically give you all the properties. You can also, let me just quickly delete this object and say, okay, I want to select an object, and now I'm going to have to right click, select from list, then the body. So you can do it other way around. So for the homework, you need a few properties. So it's the surface area the center of mass, mass, and the radii of gyration. Important, mass, not weight. So the reason we give you this kind of spread of information that we ask from you is to make sure that the closer you are to the actual correct part, the more marks you will get. So it's just a bunch of different criterion. So for instance, this one's center of mass around this plane is 0 because it's mirrored around that plane. So now someone who makes absolute nonsense part will still get that 1 mark, but the rest you won't get marks for. You won't get marks for the surface area or the weight or the radii of gyration. Or let's say you have a lot of the stuff correct, so now your center of mass is close enough, so you get some marks there, but you have something completely wrong, so then the surface area will be different, or the radii of gyration will be different. It's just so that we have the most amount of information to mark it accurately and quickly. So speaking of marking quickly, very important, you must click here and say create an associative measure feature, and then also click over here and say you must display the annotation that's associative. Okay, so both of them, very important. So let me quickly do that. So then when I click OK or apply, doesn't matter, then I have this little bluish purple block. So if it is, I think if it's not associative, then I think it's just pink. So if it does, so then it doesn't update automatically. It must be this color, then it will update automatically. So you see now the mass is 0.1503 kilograms. So let's quickly say, oh, I had the chamfer incorrect. And then I want to change the chamfer to be 3 moles. Okay, then you see the mass updated, everything else updated. This is just the quickest one to see. You see, it will automatically update. This is especially important when you're in a test, you're under pressure and you realize, oh, sorry, notification on my phone. You say, oh, I got this I got this hole incorrect. Oh, change that. Now I need to go through, okay, measure, blah, 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 find the information, type it into the test. Now, if you have this one, you can just have it update itself automatically. Remember, only add it at the end, because if you add another body, it's connected to this body specifically. So that will be kind of difficult, because then we'll have to have multiple ones. You will see for the one Rubik's Cube model that you will have to make, all the bodies are separate. So then you will have to make one for one of the pieces, and then, sorry, not one of the pieces, you have to select all of the different parts. Let me quickly give you an example of how you would do that. So, but very important, if you don't have this, we will subtract marks, because it wastes a lot of our time if we have to go back and search for this information to verify that it is correct. So let me show you what you would do if you have multiple bodies. Very important. If the bodies are connected, you must unite them. Very important. But if the bodies aren't connected, for instance, that Rubik's Cube part that you will have to make, then you have to take it into account. So first I'm going to just delete this, and then I'm going to suppress this unite. Suppress that, so now they are no longer united. There are 2 parts. Let's go to solid body. You see they are 2 distinct parts. I'm just going to also fix the chamfer. There we go. Okay. So now, if you want to go measure, then use your right click, select from list. Oops. Let's click there. Right click, select from list, solid body, and then also, you must say object set first. So let me just quickly delete the single object. I want the object set. So you select this one and then this one as well. And now it gives you the information for both of them combined. I'm not unsure why the mass is currently incorrect. Oh, because, so, very important. If you have different parts, you have to apply the material for both parts. So that's why it's also important. If it's one part, just make sure that you unite them so that you don't have to do sub double. So I'm going to go over here and say, okay, this ABS apply, this one ABS apply, so that I'm sure both of them have it applied. Then it's in solid body at the moment, so I'm just going to select both of them now because it's just easier to do that, and then say measure, and then it just wanted to do the one. So let's say object set, then I want solid body, and now all of that is correct. So very important. Make sure that you actually apply the materials correctly and that you select your parts correctly. But if they are connected, unite them. If they aren't connected, then make sure you select both and both have the correct material. Okay, and then remember to add all of these, clicking both of them so that we can actually mark your work. If I can just, oh, it's on solid body, no selection filter. There we go, move it over there. Okay, so I hope that was informative, and yeah, good luck with the homework. Cheers.